Okay, it is 3 o'clock. We're going to start. I'm going to honor your time. Welcome. My name is Tran Nguyen. I am one of the teacher at Momentum Learning. This summer, we're offering pre-cal, and I think we're going to do pre-cal AP because next year, College Board is changing pre-cal into they're offering it as a pre-cal AP course where students can earn pre-cal credit. So I am going to share my screen. I'm going to show you the PowerPoints I have, and then I'm going to introduce myself. We'll talk a little bit more about the course, and then I have mini lessons. I'm going to show you how I teach, like my teaching style, and then any questions that you have, you can ask me at the end. Okay, so I will share my screen. I am a teacher at Dulles High School. It is a math and science academy in Sugar Land area in Texas. I have my bachelor and master degree from University of Houston. I taught from Algebra 1 all the way to Calculus AB. At our school currently, because it's a math and science academy, we offer Calculus AB, Calculus BC, and multivariable calculus. So think of it as Cal 1, Cal 2, and Cal 3 in college. So the kids can earn credit. College credit for that. I right now, this current year, I am teaching Algebra 2, pre-AP or AAC. That's what we call it at our school and in our district, and pre-cal AAC, which next year we're going to change it into an AP course. Since, like I say, College Board decided that they would like to add that class starting next year. So it's a brand new, and that will be the one I'm teaching this summer. I have two small babies, a boy and a girl, and then they both pre-kindergarten, so it's like really small. If you would like to sign up for the course, you can go to Momentum Learning, and that's a website, and then there's the 2023 summer and then online camp, and then it's going to be school math for us. And then the class that we're offering is AP Pre-Cal A. We're hoping to offer A and B next year, so I will talk about the A more, and then we'll talk a little bit more about the B at the end. And then they're offering a 5% discount if you register and pay by April 30th, 2023. So what is pre-cal, right? So pre-cal is for our camp right now. It's a 10-day, it's short. It's 3 hours a day from 1 to 4. And we're going to cover as much as we possibly can in that short amount of time. But there's no way I can cover the entire school year worth of material. That would be too much for our students. The pacing for that would be way, way, way too fast for them to be able to retain and know the concepts. For pre-cal, the main concept is going to be a review of Algebra 2, which the students that sign up for the summer camp should be in right now. So either they had Algebra 2 before, or they are currently in Algebra 2. So that is a prerequisite for pre-cal. We're going to start out with Algebra 2, which is power functions, polynomial functions, rational functions, log, exponential. Those are the review of the second semester of Algebra 2. And then once we cover all of that, then we're going to start trigonometry, which is going to be sine, cosine, tangent. And then we're going to do analytical tricks, graphing, verifying, proving, solving, all of that. And we're going to go over to conics, polar, parametrics, sequences and series. AP is adding matrices. Normally, we don't do systems and matrices. That currently at our school is for our Algebra 2 students. So we will introduce and taught our Algebra 2 students this year, making assumptions that the pre-cal students already know the concept and they know how to solve system of equation and they know how to apply matrices. If we do, we just touch up a little bit of it, but won't be like in depth. But for me, normally at the end of the year, I also adding limits and continuity. Introduction to calculus, because I would like my students to be ahead. So I introduced the first unit of calculus with my students before the final exam. The students is expected to do homework. You can't learn math without doing homework. I know it's summer, but if you're going to take the course, then you definitely need to do. And it's not a lot. It's not a lot, but due to the fact that it's 3 hours long, I have to teach minimum 3 to 5 lessons, right? Because the lessons take about 30 minutes to about 50 minutes to teach, depends on the content, depends on how difficult it is, Is it new? Is it something that the kids learn already? If it's something that I have learned, so I'm going to speed up a little bit. But when we get to the new concept, which is the trig function, I will slow down. So it all depends on the content of the course, but do expect homework. And I am planning on giving a midterm and a final exam, just to, it's not a grade. So I just want to know if the student retain the concepts and know how to do it. Those are the topics for AP Pre-Cal, for Part A. And this is a little bit of Part B too. This is the full year. Functions and their graphs, all functions. Linear, quadratic, square root, cubic, cube root, log, exponential, radius integer, rational functions, reciprocal functions, piecewise functions, all of that the kids should have learned, or they will learn the last term toward the end of the year in Algebra 2. Some of that is now being taught in class. Polynomial and rational functions, we're going to start with this, and then we're going to go to exponential and log, and then I would like to go to trig functions. If we have time, then I will try to squeeze in trig identity and equations. Those is a lot for 10 days, okay? The first 4 units, polynomial, rational, exponential, and log, it will be a little bit fast paced. Let's say this is the one that the kids already learned by the end of the year. Trig is brand new. It's for the whole year. This is what College Board wants in terms of the exam. If the kids decide to take AP course next year and they would like to take the AP exam at the end for college credit, they cover polynomial, rational, exponential, log, trig, polar functions, and that's how much the exam weighs. Parametric, vectors, matrices, they want us to teach, but it's not part of the AP exams. So it's going to depend on your teacher next year. Okay, whoever they have, they might cover it or they might not. I do recommend that if your teacher does not cover parametric vectors, then you might want to learn that on your own. And the reason I'm saying that is because my students, and I would say about 90 to 95% of them, want to finish with my pre-cal course, they're going to take Calculus BC. And Calculus BC is Cal 1 and Cal 2 of college credits. So it requires the student to know parametric and vectors and polar too. So I would say maybe review this, learn this on your own. If it's not part of your curriculum next year. And I say it's brand new, it's the first year, so I don't know how teachers are going to teach. I will definitely cover that because I want my babies to be prepared for the following year. This is that's the content. This is how the kids want, how AP want the kids to do it. They want procedures and symbolic fluencies. They can change equation, table, graph, word problems, all of that. Multiple representations, communication. They need to be able to justify the answers. So showing step is crucial. I don't know if you guys do competition math or no, and I know competition math is different where the kids just learn and they just do it real quick with shortcut. You can't do shortcut with AP, okay? Every steps, every line's worth a point or two. So you have to show steps and you have to write your reasoning. You have to justify your answer. So definitely that's something I'm going to have to do with the students over the 10 days course. So unit 1 on polynomial rational functions, we're going to learn how to factors. We're going to learn how to find the zeros. We're going to learn how to graph. We're going to learn how to do complex zeros. Same thing with rational functions. We're going to learn how to graph. We're going to learn how to do vertical, horizontal, slant, asymptotes. We're going to learn the holes. We're going to learn cross point. What happens when you take a function and transform it left, right, up, down, vertical stretch, vertical shrinks. We're going to learn how to solve for polynomial and rational functions inequalities. This is crucial for calculus next year. It's because there's a lot of inequalities that the kids have to do. So this is crucial for them. They do need to know how to graph. Rational function and polynomial function is crucial for calculus. Either it's calculus AB or calculus BC. Exponential and logs, those are the concept or content we're going to be covered when we talk about log and exponential. Trig functions would be sine, cosine, tan, secant, cosecant. I'm going to teach all 6. Okay. We're going to learn how to graph them. We're going to learn how to do the unit circle. We're going to learn how to write. We're going to learn how to do inverse. And then if we have time, we're going to squeeze in the analytical trig, the solving, the proving. We don't do a lot of trig inequalities, not that, but the trig equations and the properties of trig, our identity of trigs, I will cover. Polar coordinates will be the last thing if we have time. Because like I say, those 5 topics alone is very heavy. We are looking about 2 days per topic, and that's going to be fast paced. So 4 to 5 total units. That should take care of semester 1 pre-cal. Okay, and this last piece, this is going to be optional for some teacher next year, but if you would like, then I would recommend you learn that part. We are going to start out with how I teach, and then I will let you ask any questions that you would like. Okay, so I'm going to switch here. Let me go back. This is the student will receive this. Okay, they will have this available to them either the day before or the day of. So they need a printer. If they don't have a printer, there's something that they can write with their laptop or tablet. But we're going to start with power functions. And the reason I will start with this is because in calculus, there's a lot of derivatives that the kids have to do. The power function is important in terms of finding the derivative of it and knowing how to graph. So what is a power functions? A power functions is a functions with this form. As long as it looks like this, we define it as a power functions. Okay, just like log and exponential, there are restrictions, domain and range. There's a restrictions for a power function. So for A is a coefficient, is a constant. It cannot equal to 0 because when it's equal to 0, the whole function is equal to 0, and it's not a power function anymore. It's a line. It's a horizontal line, right? So that's our first restrictions. The second restrictions for this one is going to be n cannot equal to 0. Like I say, because when n is equal to 0, your degree is equal to 0. Anything raised to the 0 degree is 1, except for 0 itself. So if you have a 1, you can also get a horizontal line. You won't have a power functions. So those are the 2 restrictions that we will place for our power functions. Anything else is fair game. Okay, so that's our format. The monomial functions is a functions with just one term. Okay, like x squared, x cubed, x fifth, 1/3, x fourth, something like that. Just one term and one term only. Constants is a line, which I really don't like it. I mean, I would prefer it's not, but it is. It's just a straight line. F of x is equal to x. By now, you should know this. Okay, this is basic math, right? That is a straight line, linear. F of x is equal to x squared, or y. And this is a parabola. You need to know all parent functions. So I would recommend, even if you're not taking the summer class, I would recommend review all parent functions, review the domains, review the range, review the characteristic, review how do you find x-intercept, are there any restrictions, stuff like that. It is crucial. So know them and know them well. You need to know the graph. Remember the graph that goes with each functions. Cubic, just like its name, is an x3, right? So it looks something like this. Then quartic is y is equal to x4. It looks like a parabola because the degree is like this is 2, this is 4, but the only difference is it's a little bit skinnier, okay? Because it's take 2 to the power 2 is only 4, but 2 to the power 4 is going to be 16. Your y value is increasing as a faster pace, so it's going to be closer to the y-axis. Quintic is the power of 5. So a power of 5 would be very similar to the power of 3. And when I say similar to x to the power 4, it is going to be closer to the y-axis. And the reason for that is, like I say, the y values is increasing at a faster pace than an x cubed. So same shape. Okay, symmetry, I'm not sure is algebra 2 covered this part. But symmetry is going to help you later when you get to calculus and in terms of even odd, graphing of functions, finding derivatives, finding maximum, minimum, all that stuff. And even functions, if it is symmetric about the y-axis. So symmetric about, and the student will have this worksheet, right? There they'll have this ahead of time to print out. They're going to print it out before we start the day, but they're going to have this so they can write and keep note of. So for example, x squared, x to the power 4/3, 1 over x 6/5, those are all even functions. It looks weird. I mean, we've seen this before. We never seen those two in terms of even functions. but those are even, because this is an even number. The power is even, that number is even. So we'll make the entire functions an even functions, okay? Odd power is when it's symmetrical about the origin. Now, what's symmetric about the origin? So x to the power 3, x to the power 5, 1 over x to the power 3, 7, they're all odd functions. And we'll talk about more as we move on to our lessons, and we'll show you how to graph them, how to distinguish them, and list out all the characteristics of that. And behaviors, this is a term that the students should have learned in Algebra 2, but I'm going to change it a little bit. I'm going to make it more like calculus. I'm going to use the notations that the kids going to have to get used to. So an x squared, we all know what an x squared look like. And behaviors deal with what happened at the end, right? There's two ends of the graph. So x squared look like this. We want to know, hey, what happened to the left and what happened to the right? To write the equations, we're going to use limit, okay? This is a calculus notation. So limit as x approaching, there's two signs. Left means negative infinity. F of x is your function. This statement means what happened to the y when your x's go to the left. Okay, that's what that notation means. And you're going to put equal to, you look at this picture and say, okay, where's the left? Here's the left side, my graph going up. So my y is going to get bigger and bigger and bigger. So that's going to go to infinity. And then there's one more side, the right side. So you're going to do the same thing. You're going to write limit as x approaches infinity of f of x. So what happened to the y values or the functions as x go to the right? So as x go to the right, the graph's going up and it's going to be to infinity. The negative in front, you should know, that's reflections over the x-axis. So instead of open up, it's now open down. And it's an even function is because, see this line right here, that's the y-axis, is symmetrical, right? The even, this is an even function, symmetrical. X cubed, this is the graph. So when you write the limit, you're going to write x is approaching negative infinity, f of x equal to, we're going to write limit of x approaches positive infinity, f of x. We're going to look at the graph. We're going to ask ourselves, what happened when x go to the left side? What happened to our graph? So the arrow is pointing down, that's negative infinity. This is pointing up, that's positive infinity. Okay. And it is odd power because it's symmetrical over the origin. It's got reflections over that one. So tie it to geometry, that's rotational length, 180. All right. And then we're going to do just one or two. And then what I do is normally I do one. I'm going to give one to the kids. I'm going to ask them, hey, let's do this one on your own. I'm going to time them. The problem that my students, my current students that they have, is not the content. It's how long does it take for them to finish. So when they do it with me, they say, oh, this is easy. But when they do it by themselves, they might get stuck. So I'm going to tell them, hey, this is the okay problems. This type of question should only take you 2 minutes, 3 minutes max, no more. So when I teach the kids, I will tell them this type of problems, 2 to 3 minutes. Try to push it a little bit less so you can save time and you can go back and check. And that's how you get better on quizzes and tests. Just be mindful of the times when you do your homework because you don't have the luxuries of like hours upon hours when you take quizzes and tests. It's a time limit, so you have to work faster and work smarter. So for example, we're going to go over example 1, 3x to the power 6, that's an even number. So expect symmetry y-axis, right? On that piece. So about y-axis, and you need to memorize your functions. You say, okay, x to the power 6, that's even. This will be like a parabola, just a little bit closer. What is the 3 going to do? That's a vertical stretch. It's going to increase your y by 3. And so just, there's no up and down. There's no left and right shift. So the graph going to stay at the origin. And then plug 1 in, you get a 3. Plug -1, you get a 3. The rest would be kind of like points you can plug more in, but that's just more than enough. Domain for this one, you need to memorize all real, always, unless we modify the functions, but this type of function will always be all real. The range for this one will never be all real. It's always going to be something to infinity or negative infinity to something, including, it's a bracket. Try to write this as interval notations. And the reason why I'm saying that is because College Board like interval notations more than inequalities. You can write this as a set notations, If you don't know how to do set notations, you can go look up, but this is a set notation. This is an interval notation. Okay, so we normally, when they write for college board, they use this one more. X-intercept is going to be a 0, 0. It doesn't have to have an x-intercept. It depends on the functions. It will always have a y-intercept in this case. Increasing means going up. When you talk about increasing, x, left to right. You look at your x and you look at left to right always. So as you go from left to right, you ask yourself, is your graph going up? Is your graph going down? Okay, so left to right, my graph going down here. When you write your decreasing interval, you need to write it as x. Use your x, never your y. Always. So negative infinity to here, and we're not going to put bracket ever. College, like AP, they don't use bracket here because you don't know what happened at that point. That's called critical numbers. Okay, that's where you get your max and your min. So we don't ever put bracket when we talk about decreasing or increasing, always parentheses. Increasing, go up. So from left to right, your graph is going up here. So you're going to start at 0 and you're going to go all the way to infinity. Okay, what does discontinuity mean? Gaps, holes, vertical asymptotes, they're a jump. Like there's a disconnect of the graph. So when you graph it, you have to pick up your pencil. So for this one, when I graph this one, I don't have to pick up my pencil. That means there's no discontinuity at all. Okay, so for example, this one, there's a discontinuity. See how there's a hole right there? Or when you have something like this, there's a discontinuity, there's a gap. When you get to calculus, we separate into 2 types, and then calculus teacher will teach you that part. So in this case, there will be none. Remember, and behavior on the other side, write limit, limit. Get used to writing this. It's going to help you so much in calculus. Okay, set it up like that. Look at the graph. Ask yourself, is it going up? Is it going down? There's only 2 ways it can go, up, down. Normally, like horizontal, we talk about that when we get to rational. Okay, power function, we deal with that. So when I finish teaching, I will give the kids time. I will tell them, okay, babies, you're going to try this one. The amount of time it's going to take me, I'm going to like add more time for the kid. So I'll say, this one, 3 minutes. Okay. So they will do, and we're going to check. I'm going to show them the key, and I want to self-check because it's going to be hard for me to check all my babies online. If it's a face-to-face, I can walk around and can do that, but online is going to be difficult. So the kids need to go to self-check. So I will show the answer for this, and they say, okay, look at this and tell me what's wrong. And they can ask questions. They can say, oh, Miss Wynn, I got the end behavior wrong. Can you explain that? And I will go over. We'll say, okay, let's go back to end behavior, and we go from there. So to be successful in pre-calc, strong algebra 2 foundations. Okay, you have to go back and review all the functions. Hold on to all those notes. Hold on to those, homework that your teacher been giving you on polynomial, rational, exponential, and log. Hold on to those because you're going to use them again in pre-calc, and you're going to use them again in calculus. Okay, that's normally is going to be my teaching style. I'm gonna slow. I mean, I went fast is because this is a sample, but can be too slow because you guys are paying me to teach for the kids to be ahead. So I'm gonna try my best to cover the content that I feel like is important for the kids in pre-calc, because I've been teaching this for like 10 years, so I know what the kids need. We're gonna skip some things, right? If this is not something they need in calculus, I'm like, okay, we don't need, we're going to move on. If this is something that's going to be extremely important in calculus, I'm going to spend a little bit more time working with the kids. The next day, homework key will be posted. If there's questions about homework, I can spend about 5-10 minutes going over. But the main, the majority of the time will be me teaching, letting the kids do the problem, checking, and then teaching on that. So I expect about 3 to 5 lessons maximum. I would say 3 to 4 is a good pace for the kids. Okay, so I'm going to stop sharing. I'm going to go back, and we're going to go, and then any questions that you have, you can unmute and you can start asking me, and anything at all, and I can answer the questions. If you don't have anything, I would like, before you go, just a piece of advice, regardless of whether or not you sign up. Like I say, Algebra 2 is crucial. So even if you don't take the course, please review, hold on to those 4 functions I was telling you about. And it's going to be, you can write down polynomial, rational, log, and exponential. The first half of the semester 1 pre-cal is going over those 4. So if you could get a head start, that's where you're gonna be. Because the trick is very easy to teach. It's actually very easy to learn. You just, there's tricks for that that I can teach, but the rest, the other 4, you have to know them. So go back and hold on to those worksheets, hold on to those notes, and just review them. There's a lot of contents and concepts that I have to make the assumptions that the students sign up for the summer program, they will learn and they will know. So if you don't know, I would recommend you review them before you sign up. Okay, because those 4 is going to be super quick and super fast. Those 4 units, I'm going to go through them. And then because I need to move on to trade. That's a new unit, and I would like to teach that before the end of the 10 days. So think of it about 2 days per unit. So 2 days on polynomial, 2 days on rationals, 2 days for log. The exponential one I can combine with the logs, and then about 3 days or so, 3 to 4. I'm saving that for trade.